Question 1. The name of the object below is point G, ray FG, line segment FG or interval FG, or line FG. Part of a line with fixed endpoints is known as a line segment or an interval. You'll notice it doesn't have arrows on both ends, so we know it's got fixed endpoints here. Line segments or intervals can be named for their endpoints. So the endpoints are named F and G here, so we can name the above as line segment FG. That's option C there. Another way of saying it is interval FG if we wanted to go that way. Question 2. The type of graph shown below is known as a bar graph, a sector graph, a column graph, or a histogram. Okay, this one you could be forgiven for naming it as a column graph because it's certainly got columns, but this is a special type of column graph because it's got special features. It's got a half a unit of the horizontal axis sort of missing from the very start of it, and it's got every column touching each other. It's got the frequency on the vertical axis and the scores on the horizontal axis. So this is a special type of column graph, so the best answer there is histogram. We call that one a histogram. Question 3. 0.2 has how many decimal places? The number of decimal places are the number of digits to the right of the decimal point. In this case, I think you can see there's only one digit to the right of the decimal point, so we'd say that 0.2 has one decimal place. Question 4. Solve y over 6 equals 3. Solve an equation by moving all the numbers away from the letter until the letter's on its own. The way we move numbers is by doing the opposite operation to both sides. So to get the letter on its own, we need to move that 6. Now that 6 is underneath, it's on the bottom of a fraction, so that 6 we consider to be dividing into the y. So the opposite of dividing is multiplying, so we're going to multiply 6 by both sides. Now on the left-hand side, this is what we wanted. We have a divide by 6 and a multiply by 6 that effectively cancel each other out, leaving us with just the y. We wanted the letter on its own. That's how you solve an equation. On the right hand side, we just have to do what the calculation says. 3 lots of 6 is 18. So final answer, y equals 18. Question 5. Simplify 2/7 plus 5/7, leaving your answer as a whole number. When adding fractions, we add across the top. So we'll add across the top. 2 plus 5 is 7. And we keep the bottoms the same. So we end up with 7 over 7. Now we also look to simplify if possible. Now 7 over 7 is really 7 divided by 7, and that goes once. So anything over itself ends up having 1 as its equivalent answer there. Okay, so that's the process. Add across the top, keep the bottom the same, and look to simplify. Question 6. Write your answer in simplest index form for j squared cubed. When a power is put to another power, we've got the power of 2 there being put to a power of 3. When a power is put to another power, we multiply the indices. So here we'll multiply the 2 and the 3 together, making j to the 6. We'll just follow that rule. Question 7. Find the area of this triangle. It has a base of 18 and a perpendicular height of 10 centimeters. So this has a formula to it. We'll have a formula on the top line, and then we'll look to substitute all the numbers in straight underneath that formula. Then we'll calculate our answer from there, and we'll also have a last thought about getting proper units. We'll check which units we should be using. So our formula here is the area of a triangle, and that is half the base times the perpendicular height. Here we have a base of 18 centimeters and a perpendicular height of 10 centimeters. So on the second line here, straight underneath where we've got the formula, we'll look to put the numbers in that we know from the question. So A equals a half of B times H, just to be a bit simpler there. Stands for base times height. So we have half of the base. Now the base is 18. So we're going to have a half times the 18 there. And the H, the perpendicular height, is 10. So we'll have half of 18 times 10 there once we've put all the numbers in the right spots. So when we calculate that out, we get 90 centimeters squared. So the numbers turn out to be 90 when we do that multiplication. We started off with centimeters, normal everyday centimeters in our question, but when we're working with area, we have to have units that are centimeters squared. It's almost like the centimeters from the 10 and the centimeters from the 18 are multiplied together, and you know when you multiply one thing times itself, it gets squared, doesn't it? So area is measured in units squared, in this case centimeters squared. Question 8. Express 0.7 as a percentage. To convert a decimal to a percentage, we multiply by 100. Now multiplying by 100 involves moving the decimal point 2 places to the right, one for every 0. So you see when multiplying by 100, 100 has 2 zeros in it. So we're going to move the decimal point 1 jump for every 0, or 2 places to the right. So if we do that, the 0 goes from before the 7, 2 jumps to the right. Now when there's a jump, that second jump there doesn't seem to have a digit above it. To be careful here, we put a 0 in so it holds its place value. Everything is in its proper place then. If we have a jump that we haven't got digits for, we'll put a 0 in there. So that means the decimal point goes from before the 7 to after the last 0 there. And that ends up converting 0.7 to a percentage of 70%. So it's not 7% like a lot of students might think, it ends up being 70% when we multiply by 100 and move the decimal point appropriately. Question 9. Find the value of the shorter side, x, in the diagram below. Give your answer correct to 1 decimal place. Alright, so for any right angle triangle, a square on the hypotenuse equals the sum of the squares on the other two sides. So I think you'll be thinking Pythagoras here. So we'll have x squared equals 19.1 squared minus 12.2 squared. So what we're doing, because we're finding a shorter side, we use a minus in between the two squared numbers, and it's best if you have big number minus small number, so we'll go the biggest number, the hypotenuse bit squared, and minus the one of the other shorter sides squared. So that's the way we find a shorter side. We have a minus in our Pythagoras set up there. So let's process that. We have x squared equals 19.1 squared. Now 19.1 squared is 364.81. Putting it into our calculator. and 12.2 is 148.84. We'll just process that properly and we'll end up with, on the right hand side, 215.97. Just use your calculator for those bits. And then we have x squared, but we want x in the end. So how do you get rid of how do you undo a squared? You square root both sides. There's a number on our calculator, a symbol on our calculator that can handle that, a button that helps us there. So we'll square root 215.97 and get our final answer of x equals 14.7. Now I've rounded that off to one decimal place, and you can do that on the calculator carefully. But and also we double check that our answer makes sense here, because 19.1 is the hypotenuse, we'd call that, of our right angle triangle. That's the longest side. So we're expecting or hoping for an answer that's less than 19.1. If it's not, we've done something wrong perhaps. So there's a lot happening there. Question 10. Simplify by collecting like terms 10x squared plus 5x plus 3x squared plus 2x. Now you can only add and subtract like terms, and like terms in algebra are any terms with the same letter and power. Now they've all got the same letter, these four terms, but not the same power necessarily. You've got a 10x squared and a 3x squared that we can consider to be like terms, so we'll be able to merge those two together. And we've got a 5x and a 2x, so they've both got the same letter and power as each other, so we can merge those two. So we can't certainly mix up all these together. So 10x squared plus 3x squared makes 13x squared, and 5x plus 2x is 7x. So we'll end up with that answer C there. 13x squared when we merge the x squared terms together, plus 7x when we merge those two together. Got to be a little careful there. You can only add and subtract like terms, and they need the same letter and power to be able to combine when you're plussing and minusing there.